So we're going to begin by doing something that might seem very basic, and it's not an insult to anyone's intelligence, but it's really going to help us lay the foundation for where things are going in a different sense. And we're going to build a resource that we're going to use quite frequently. So let me start actually by grabbing a ruler and unfold my ruler just so it doesn't get in my way. And I'm going to draw a horizontal line. If you have notebook paper, you don't necessarily have to do this, of course. And I'm going to draw another one here. I'm going to make a little T out of it, make a little table. There we go. And I'm going to count. And that's it. I'm just going to count. That's what this whole lesson really is about until we get to the end and really notice the patterns. So I'm going to start with 1, of course, and then we're going to have 2, 3, 4. And then the obvious question is, where is this going to stop? I think I'm going to stop at 12. That's a good place. 8, 9, 10, 11, 12. There we go. So I probably drew my line a little too long, but whatever. So in this case, we just counted up by 1 every time, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No big deal there. And so we counted by 1s, right? So now let's do the same thing, but we're not going to count by 1s. We're going to count by 2s. And we're going to start with 2. And so when I count by 2s and then I go up by 2, well, I go up to 2 and I get 4, and then I go up 2 more and I get 6, and then I go up 2 more and I get 8, and then I go up 2 more and I get 10, and you can see where this is going, right? And then I go up 2 more and I get 12, and then 14, 16, 18, 20, 22, 24, and we'll stop there. I think that's a good place to stop. It's important, if you're writing this down, that you have things lined up vertically as much as possible. It's going to get a little sloppy if you don't, and what you're building is not going to look very nice and won't be very usable. So you see what's happening. We have counted by 1s, we've counted by 2s. Now let's count by 3s. I'm going to put a 3 here because that's what I'm counting by. And we'll start with 3. And if I start with 3, and then I'm going to go up 3 more. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It's easy to lose count, even when you're doing something like that. That sort of happened with me right here. Well, right here, I did 33 and then was going to be off, so be careful. Okay, so how far down are we going to go? Well, I think we should go as far down as we went across. So let's do 4s, and we're going to do 5s, and we're going to do 6s, and we're going to do 7s, 8s, 9s, 10s, 11s, and 12s. And the straighter we can make this, the better it'll be. So if you have notebook paper, it's going to be very convenient for you. And hopefully you'll see where this is going when we get to the end. So let's start with 4, and we're going to go for 5, 6, 7, 8, 9, 10, 11, 12. There is no shame in using your fingers, by the way. They're mathematical tools and you can use them. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Okay, let's do 5s, and these are ones that, at least when I was a child, it was easy to count by 5s. You know, counting by 3s was a little more difficult, but 5s was pretty easy because you would be like, oh, well, 5, 10, 15, 20, 25, 30. So every other number ends in a 5, and then the other numbers end in 0. So 5 and 10, and 15 and 20, 25, 30, 35, 40, 45, 50, 55, 60, and we'll stop there. Once we get to that last column, I'm going to try to keep it straight, but mine's starting to go a little bit to the left. Okay, now we're going to count by 6s, but are we going to count by 6s really, or are we going to start noticing patterns that will help us sort of have a shortcut, okay? So look across the very top, right here, where we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, and now we see 1, 2, 3, 4, 5. Well, there's really no secret what the pattern is here, right? So this next one's going to be 6, because that's where we would start anyway, right? And then 7, and then 8, and then 9, and then 10, and then 11, and then 12. Okay, and then now here we have 2, 4, 6, 8, 10. Oh, it's the same pattern we have here. So counting down is the same as we had across. So we're starting to see some patterns that are emerging in what we're doing. So if I count by twos this way, then I'm also counting by twos this way. So the second row corresponds to the second column. So this is 12, 14, 16, 18, 20, 22, 24. Okay, fine. Well, then, if the third row is counting by threes, then maybe the third column in this little corner here, quadrant, if you call it if you want to, is going to also count by three. So these are 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Okay, I hope you know what we're building. I'd like to think that you do. So again, if I'm counting across by ones, then by twos, then by threes, then I'm also counting down by, notice what I'm writing, by ones, by twos, by threes, by fours, by fives, sixes, sevens, 8, 9s, 10s, 11s, and 12s. And you might be looking and saying, well, if I already have these numbers here, then why am I putting them up here? We'll get to that in a minute, but you probably already know the answer, right? I think so. At this point, we can fill in quite a bit of this without even doing too much thinking. So we could continue to copy our previous answers. We could say, well, the fours go this way, so the fours go this way. So I'm still not really counting by fours again. I've already counted by fours, and now I'm just copying my answers in a different direction. So 4, 8, 12, 16, 20, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. It's about the neatest I've ever made this chart. And you can see where the next one's going. We counted by fives, so we can count by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, now we obviously have a corner that we've not filled in, and we still have to do some thinking, but finding the patterns in this is starting to become a little more obvious. So what we're truly building, and I hope you notice, is a multiplication table. Multiplication is repeated addition, and we're repeatedly adding 1, or repeatedly adding 2, or repeatedly adding 3. So a multiplication table. So if you're looking at this and saying, well, can't I just find that on the internet? Sure, yeah, go for it. That's great. But the process of doing this is helping us gain an understanding that multiplication and addition are sort of the same thing in a way. Again, multiplication is repeated addition. When you first learned multiplication, you probably learned multiplication in the context of something like this. Let me grab a scrap piece of paper. And someone would probably say, what's 5 plus 5 plus 5? Plus 5 plus 5 plus 5, and you were like, oh, 1, 2, 3, 4, 5, 6 fives, and eventually you learned to say, oh, this is really 6 times 5, and that's 30. That's exactly what we're doing. I'm doing 5, 10, 15, 20, 25, 30, 6 of them, and that's what I'm doing, the repeated addition, which is multiplication. Okay, so we're going to continue this process, fill in this corner, and probably notice a couple other patterns, and then that'll be it. We'll have this resource at our command. Now, if you have this memorized, that's great, but it's really going to come in handy when we're doing other things, and I need to look at this and say, okay, I need two numbers that multiply to give me 24, and if you can't think of them off the top of your head, then you have one here. 6 times 4. You have 4 times 6, same thing, sort of. You have 3 times 8. You have 8 times 3. You have 2 times 12. And you'll be able to find things and identify them. So it's going to come in handy just to be able to look at it. So let's keep going. Let's fill in the 6s. 6, 12, 18, 24, 30. 30 plus 6 is 36. 36 plus 6 is 42. 48. 54. 60, 66, 72. They're starting to get harder. When you're counting by ones, everybody can do that, right? When you're counting by twos, that's easy. 3s, 4s, 5s are easy. When you get to things like 6, then you have to think a little harder sometimes because you're at 66 and you're like, okay, 67, 68, 69, 70, 71, 72. And counting by 6s isn't nearly as intuitive as others. Let's do sevens. Not easy at all. 7 plus 7 is 14, plus 7, 21, plus 7, 28, plus 7. Let's add 7 again, and we get 42. There he is. 6 times 7 is 42. 7 times 6 is 42. Same thing. Interesting, huh? I think so. 7 added to 42 is going to give me 49. And then 56, 63, 70, 77, and then one that a lot of people just don't know off the top of their head, 7 times 12 is 84. Okay, so let's keep noticing some patterns here. I hope you notice a couple things, and I want to point to this column, and I want to point to this column. So obviously the pattern on the 10s is something that you already knew, and the pattern on the 11s is something that you probably already knew as well, maybe. But if you wanted to, and if it wouldn't mess up my spacing, I could just go ahead and fill these in. I really could. Like, I know what the next one is. Like, I'm going to a little bit. It's 80. And then the next one is, well, 90. And the next one is, well, it's, I'm going to make up a word. It's 10T. It's 10 with a 0, so it's 100. And then that's 11 with a 0, so 110. And then a 12 with a 0, so it's 120. Okay? Or this one. The next one's 88. And then the one after that is 99. And then the one after that is not as obvious, so I'm not going to go there yet. Okay, actually it's already on the paper, but I'm not going to go there yet. So I have some other things that I've already filled in just by noticing patterns. So let's keep going. Counting by 8s. By the time I get to this one, I better have 80 or I've messed up, right? So 40 plus 8 is 48. 48 plus 8 is 56. I hope you're noticing some things that are similar here. Not similar, they're exactly the same. Or like 48, 48, 42, 42, 35, 35. Okay. Let's add 8 to 56, and we're going to get 64. We add 8 to that, and we get 72. Add 8 to 72, and we sure enough get 80. Add 8, we get 88. And then we add 8 to that, and we get something that's not as obvious. A lot of people don't know, but it's 96. My table's getting a little crooked. Almost done. Let's count by 9s. 9, 18, 27, 36, 45, 54, 63. You know what comes next? 72, 81, 90, 99. And then we're going to add 9 to we're going to add 9 to 99, and it's going to give us 108. We're almost finished with this. This next row is super easy. We already know it. 60, 70, 80, 90, 100, 110, 120. Okay, we got this one too. So 55, 66, 77, 88, 99, 110. Okay, now we have to think a little bit because the pattern sort of breaks apart. As we move from 99 to 110, the pattern breaks apart. And so we move forward. If I was to add 110 and 11, so basically 110 plus 11, it's going to give me, well, 1 here and 2 here and 1 here. So 121 is next. And then I add 11 to that, and I get 132. Okay? And let's finish by adding 12s. These aren't the easy ones. So 72, 84, 96, 108. If I added 12, I'd get 120, so I'm on the right track. 132, 144. And now you have a multiplication chart, 1 through 12. Again, you could have Googled it, but now we have built it, and in building it, we've gained an understanding. And let me circle a few numbers that are somewhat important. Actually, I'm not going to circle them. I'm going to highlight them in yellow. And they are what we call perfect squares, meaning if I took a number and squared it, meaning I multiply it by itself, that's what I'd get. So a perfect square is a number like 1 times 1, which is 1. Or like 2 times 2, which is 4. Or 3 times 3, which is 9. Or 4 times 4, which is 16. Or 5 times 5, which is 25. Now, you can clearly see which numbers I'm highlighting, and if you wanted to, you could just keep going straight down, diagonally, not straight down. You could go diagonally downward to the right, and that would work. So 36, 49, 64, 81, 100, 121, and 144. And so those are our perfect squares. There's an infinite number of them, but these are the perfect squares of 1 through 144. Now, one more pattern I want to point out, and it is this. Everything you have up here, you also have down here. We talked about that earlier, actually. I was pointing at 72, and I said, oh, look, 72, 72, 63, 63. Let's get crazy with it. 33, way down here, is 33. And the reason why is because 11 times 3 is the same thing as 3 times 11. So there are a lot of patterns here. And now we have a multiplication table that goes through 12 that we built ourselves. Hopefully we gain some understanding in the process.